Okay, solving special systems of equations. Okay, so by special systems of equations, we mean no solution and infinitely many solutions. Okay, the not so special one is one solution. So, as we've discussed before, when we looked at how to solve a system by graphing, no solutions looks like that. Okay, so when you have parallel lines, that's what your no solution looks like. Okay. Another name for no solution is inconsistent equations. Okay, or I think Alex just calls it inconsistent. Okay. So here's how we would determine using elimination if we had an algebraic system to solve. Okay, let's say we had this system 2x plus 3y equals -6, -2x minus 3y equals -4. Okay? So you should see here that both the x's and the y's are going to eliminate. So because these both eliminated, we're left with 0 on the left side of the system. And on the right side of the system, we're going to have -6 and -4 and -10. Okay? So we wind up with a false statement. This is junk. So this is false statement. Okay? So when you get both variables canceling out and you get a false statement, that's how we're going to determine algebraically that we have an inconsistent solution. Okay? An inconsistent system of equations. Okay, the next type of special system, infinitely many solutions, you should remember, are coinciding lines. Coinciding lines means two lines that are exactly the same, that are right on top of each other. And these intersect everywhere, so that's why it's got an infinite number of solutions. So these are coinciding lines. Okay? For the other name for the system, these are called consistent dependent. Oops. All right. How to determine using elimination. Let's say we had 2x plus 3y equals -6, and then -2x minus 3y equals 6. Okay. So if we try to solve this here, that's going to eliminate, that's going to eliminate. Left with 0 over here, -6 and 6, 0. So for the no solutions, I had a false statement. 0 equals 0, that's a true statement. Okay? So for no solutions, the variables are going to cancel, and you're going to get a false. For infinitely many solutions, the variables are going to cancel again, but you're going to get a true statement. Okay? And then last, one solution, of course, that's where we have two lines that actually intersect. Okay? So let's say they intersect right here. Let's say this is the point, I don't know, 3, 2. Okay, so the solution to this system would be x is 3, y is 2, so these are intersecting. lines. Okay, so this is called a unique solution. Actually, I don't know why I put this in parentheses, at a point. So what we'd say, this one has a unique solution at the point 3, 2, okay, or whatever, whatever point that the lines would happen to intersect at, all right? Algebraically, let's say we've got 2x plus 3y equals 1, 3x minus 3y equals 4. Okay, so see, these are going to eliminate. 5x equals 5. X would be 1, and then of course we're going to substitute back into either equation. Oh, sorry about that, my phone just dropped. Okay. Yeah, I'm not going to delete and start over again. Sorry. Okay. So I'm going to substitute the x is 1 into the top equation. We're going to go 2 times 1 plus 3y equals 1. 2 plus 3y equals 1 minus 2 minus 2. 3y equals negative 1 divided by 3 divided by 3. So y would be negative 1/3. Okay, so this would have, as a solution, it would be x is 1, comma, negative 1/3. Okay, let's take a look at some questions like you're going to see in your assignment. Okay, so we have two systems and we have to choose the best description of the solution, and if applicable, we have to actually give the solution. All right, so on this one, the x's eliminate, the y's do not, equals 8. So that means y is going to be 1. So I'm going to substitute that into the top one. Again, doesn't matter whether you use top or bottom. Let's go over here. So it's x plus 4 times 1 equals 5. X plus 4 equals 5, which means x is 1. So this one, since nothing, only one of the variables eliminated, and we actually got an actual answer for x and y, this is unique solution. So this is our one solution, and x is 1, y is 1. Okay, system B, x eliminates, y eliminates. So we have 0 equals 3 and negative 3 is 0. True statement. That means it's infinitely many solutions. All right, let's do the back. Same thing here. So this doesn't eliminate, this doesn't eliminate. Well, I've got a 7y over here, I need a negative 7y down here, so I'm going to multiply everything by negative 1 to create that negative 7y. So 4x plus 7y equals 9. Negative 3x minus 7y equals negative 5. X equals 4. Okay, I'm going to substitute that into the top. So we're 4 times 4 plus 7y equals 9. 8 plus 7y equals 9. Minus 8 minus 8. 7y equals 1. So y is going to be 1/7. So this one's going to have a unique solution. X is 4, and y is 1/7. All right, the last one, that eliminates, so we've got 0 and equals 0, true statement, so that's going to be infinitely many solutions.